Welcome to my channel. Today we are going to discuss about the topic need for modulation. So we already know what is modulation. So why are we going for this modulation? Basically, what do we do in modulation? In modulation, we take up a low frequency message signal, which is the information signal that we want to transmit. However, we don't transmit our message signal as it is. Rather, we try to superimpose our message signal on a high frequency carrier wave. So we can see that here in this picture, we have two signals. One is our message signal, which is a low frequency signal, while the other one is the carrier signal, which is a high frequency signal. So why do we really need this modulation? In case of modulation, some parameter of the carrier wave changes with respect to the instantaneous value of the message signal. So what is the need for modulation? Let us see the need for modulation in the coming slides. The first need for modulation is the size of the antenna. So when we modulate a particular signal, how does the size vary? Let us assume a signal which is an audio frequency signal. This signal does not undergo any modulation and the frequency of the signal is 1 kilohertz. So, since the frequency is 1 kilohertz, let us try to find out the wavelength of the signal. We already have a standard equation, C is equal to F into lambda, where C represents the velocity of light, F represents the frequency, and lambda represents the wavelength. So, from this equation, for a frequency of 1 kilohertz, if we try to find out the value of our lambda, it is nothing but the velocity of light C divided by the frequency of the signal, which is 1 kilohertz. And we get the value of lambda to be 300 kilometer. Now, to find out the exact size of the antenna, let us use the formula L is equal to lambda by 4. So this is the formula to find the size of the antenna. So we already got 300 kilometer. So 300 kilometer divided by 4 gives us 75 kilometer. 75 kilometer is too huge, right? It's very, very large value, which means that the size of the antenna the antenna size will be too big. So let us find out what exactly happens when there is modulation. So when there is modulation, we superimpose our message signal over our high frequency carrier signal. So let us assume that the modulated signal, right? The modulated signal is at a frequency of 1 megahertz. So in this case, if we try to find out the value of lambda is equal to, again, it is 3 into 10 power 8 divided by 1 megahertz. So in this case, the lambda value turns out to be 300 meters and the size of the antenna comes down to 75 meters. So we can see that in case of the frequency or the signal where we do not have modulation, the size of the antenna is too big. Whereas whenever we use modulation, the size of the antenna comes down to a very low value, which is 75 meters, which is highly tangible. So the next reason why we go for modulation is multiplexing. In this case, let us assume that there are 3 signals, right? Signal 1 with frequency F1, right? And signal 2 with frequency F2 and signal 3 with frequency F3. Let us assume that I am going to transmit these 3 signals at a time and all these 3 signals have almost similar frequency, somewhere between 1 kilohertz to 10 kilohertz. Let us assume that all of them have same frequency, maybe 4.1K, 4.2K and 4.3K. When we transmit this signal at a time together, there is a very high probability that all these 3 signals will get mixed up. All these 3 signals will interfere with each other. Hence, what we do when we go for modulation, these 3 signals, which were at 4.1, 4.2, and 4.3 kilohertz, get converted to according to their high frequency signals, which is the carrier signal. If we are assume that we are using a carrier signal which is of high frequency, these 3 signals get converted to 10.3 gigahertz, 10.4 gigahertz, and 10.5 gigahertz. Let us assume. In this case, since it is 10.3 gigahertz and 10.4 gigahertz, they are separated far apart. So even if I try to send these two signals together, they will not interfere with each other. Hence, by going in for modulation, multiplexing of different signals becomes easy. Multiplexing of different signals with same frequencies become very, very easy for us. That is the second reason why we go for modulation. And the third reason being radiated power by antenna. So in an antenna, the radiated power is usually indirectly proportional to lambda square, which means greater the value of lambda, lesser will be the power. So when we go for modulation, right, that is when we apply our low frequency signal over a high frequency carrier, what happens is the frequency of the signal or the modulated wave increases. So frequency increases. So which means that if frequency increases, our lambda value will decrease. If lambda value decreases, our power, since lambda is inversely proportional to the power, power will increase. So the power with which the signal is radiated will be high, and hence it can travel over a very long distance. The next reason why we go for modulation is the bandwidth. Definitely, whenever we go for modulation, the bandwidth will be improved. For low frequency signal, when there is no modulation, the frequency is very, very less. Hence, the bandwidth is going to be low. When we go for modulation, we impose the signal over a high frequency signal. As a result, the bandwidth of the signal improves. I hope you have had a nice session.